Hey there, I'm Marty Sakata, host of Resilient Alpha. You might know me from the Ivy Family Office Network, almost 3 decades of family offices and big shots collaborating on alternative investments, strategy, and good causes. That's the fuel for this podcast. Why Resilient Alpha? Simple. Why do some funds and managers crush it and others crash? We're cracking that code, redefining alpha, and bringing top brains to unpack asset classes and hot alpha ideas full throttle. Buckle up and enjoy the ride. Today, we're thrilled to welcome Darwin Ling, the founder and general partner of Good AI Capital, a venture firm dedicated to backing early stage AI companies that promise both profitability and positive impact. Many people in our group know Darwin as the AI whisperer. With a career spanning technology, entrepreneurship, and investing, Darwin brings a unique perspective to the AI revolution. As a builder, he founded Smarter Me and successfully exited. He also held leadership roles at tech giants like Oracle. And then Darwin's mission has been to solve for AI to solve the world's toughest problems, from healthcare to finance, while delivering strong returns. A philosophy he calls doing well by doing good. Darwin's insights are shaped by his deep experience in Silicon Valley and his global outlook on the AI landscape, including the contrasting dynamics between powerhouses like the USA and China. At Good AI Capital, he's backed a portfolio of cutting edge companies in fintech, healthcare, and enterprise SaaS, leveraging his knack for spotting transformative technologies early. Darwin's at the forefront of the new AI industry investment strategies. He guides founders and investors alike through his fast evolving frontier. In this episode, we'll dive into his take on AI as an investment thesis, the future of AI enabled applications, and how he navigates complexities of proprietary versus open models in a competitive global market.
Hi, this is Marty Sakata, and we're back for another episode of Resilient Alpha. Today's guest is Darwin Ling, the founder and general partner of Good AI Capital, a venture firm dedicated to backing early stage AI companies that promise both profitability and positive impact. With a career spanning technology, entrepreneurship, and investing, Darwin brings a unique perspective to the AI revolution. He's not just an investor, but a builder himself, having founded Smart Me, an AI-driven sales coaching platform that he successfully exited, and held leadership roles at tech giants and innovative startups alike. His mission at Good AI Capital is rooted in the belief that AI can solve some of the world's toughest problems, from healthcare inefficiency to financial inclusion, all while delivering strong returns. A philosophy he calls doing well by doing good. Darwin's insights are shaped by his deep experience in Silicon Valley and his global outlook on the AI landscape, including the contrasting dynamics between powerhouses like the USA and China. At Good AI Capital, he's backed a portfolio of cutting edge companies in automation, robotics, autonomous driving, healthcare, and enterprise applications, leveraging his knack for spotting transformative technologies early. As AI continues to redefine industries and investment opportunities, Darwin is at the forefront, guiding founders and investors alike through this fast evolving frontier. In this episode, we'll dive into his take on AI as an investment thesis, the future of AI enabled applications, and how he navigates the complexities of proprietary versus open models in a competitive global market. Darwin, thanks for joining us.
Absolutely. Great to be here.
So, before we get started, because I've known you for a few years, maybe you can talk about your journey, how you got to where we are. Could take a couple of minutes and talk about that, and then we'll jump into the questions.
Okay, sure. So, hi everyone. My name is Darwin Ling. I'm the founder and general partner of Good AI Capital. At Good AI, we focus on early stage AI companies, particularly what we call apply AI, with a strong focus in healthcare, enterprise, as well as automation. So we have what Marty mentioned that I think our name is called Good AI Capital. The good really stems from what we call doing good, doing well. So we want to partner with founders and entrepreneurs that really have a deep desire to use technologies, of course, in this case, to tackle some of the most challenging problems faced across industries. And my journey actually as a founder and entrepreneur really kind of inspired me to get to where we are today. So I have a successful career, both as an investor, as an engineer, as an entrepreneur. So one of the great desires is that, but yet there still too many things, too many problems remain to be solved here. And actually, this is my goal and desire to really want to partner and actually nurture the next generation of entrepreneurs, because at the end, I think the financial prosperity is going to come from entrepreneurs, the next generation. So I think this is actually something that we feel deeply about. Strongly about, and that's led to me my transition in career as an entrepreneur to be a full-time venture investor.
Right. So it seems like you've done work in fintech, healthcare, enterprise SaaS. What's led you to look at all of this, different portfolios of different technologies? Is it the commonality of AI, or what's led you to that?
Yeah, I think in general, as of today, I mean, everybody is looking at the Magnificent Seven, right? So, every AI, you have to talk about OpenAI or NVIDIA. To us, I think this is a good trend. There's a new opportunities. What we evolve as everybody must have heard of, is called large language models. Yes, it's a generative AI. It has a lot of promises, but the promises has not translated into some of the specific areas like healthcare, for example, right? So how can we use AI to do a better job in, say, helping the doctor to, treat patients? How do we use AI to improve the automation for manufacturing? How do we use AI to provide a more secure cybersecurity framework to protect the enterprises, right? So these are the things that we felt that there's a strong gap between it. And I think this is sort of the opportunities for us as a venture investor, where we can actually look at the earliest innovations possible to tap into the capability of this strong of AI and then apply towards those industries.
AI is kind of like that common thread, I guess, of process that a lot of people use.
Yeah, it's a tools, right? So people, I think, look at AI, it seems to like get kind of carried away with the buzz, right? AI can solve every problem in the world. But AI is just another tool. It's a very powerful tool, but you need to have the expertise. Let's say, if you want to do an AI drug development, right? You can just like find some engineer that happen to know AI quite a bit, but has nothing about cancer treatment or the biology or the chemical side of things, right? So you need to kind of have this integration of the team in order to understand and actually come together and solve these problems.
Sure. I mean, we've had Tom Farb speak many times to our group, and he's kind of, bridging these two disciplines of, healthcare labs and AI, using different types of, data models and large language models to be able to, look at cells that you're testing, et cetera. And I think you're kind of saying the same thing about cross-disciplinary applications.
Yes, absolutely. Yep.
So AI's been a buzzword. It's been around for a long time. IBM, right? It seems like IBM for 10, 15 years has been selling AI. They've got a great tennis application, and they use a little bit of in healthcare as well. But it seems like it really came to the forefront in the last couple of years, right? So from your vantage point as an investor, what makes AI a compelling story today? Any specific sectors that you look at and that you're most excited about?
Yeah, so I think we talk about healthcare a lot. So I think first of all, just to address those questions. So because of this, there's this ChatGPT moment 2 years ago. Because of that, is a newfound generation of this excitement where AI has been in place for a long time. But until the whole ChatGPT comes along, that really kind of capture the imagination of everybody that, wow, AI can do an amazing amount of things, right? But what you see 2 years ago is just the beginning, right? So now I think people are seeing like all these wonderful applications that you can tap into, and that's actually where the excitement is. So, so one area that I think we felt very excited about, we talk about healthcare, but in one area that we even feel strongly about is an idea called precision medicine. So precision medicine, for another term, actually is called personalized medicine. And what that means is a medical approach that essentially try to look at data and how do we kind of tailor a specific treatment for a very specific patient. So the goal is that you want to deliver the right treatment to the right patient at the right time.
And those are kind of like genetic based
Yeah. So
approaches where you have to find somebody's genome and then
Yeah.
deliver,
absolutely.
manufacture the medicine
Yeah.
or use some sort of their white blood cells, whatever,
Yes, absolutely.
re-engineer them.
Yeah, so basically, there are multiple, you kind of nailed it. I mean, the idea is that it's a very general term, but it has a broad different applications, right? So you talk about different therapies, for cancer therapies. So the current, kind of have this one size fits all that, you have to take these drugs in order for a patient. But every patient's profile, including the genetic, genomic sequencing is different, right? How do you find that actually genetics, mutations? So you look at that from a data perspective. And then you can actually kind of tailor the treatment for that patient. And also there's another application for like, diagnostics, how can we look at the genetic makeup of a patient so that I can potentially do an early disease detection for lung cancer. We call that a biomarker detection. So biomarker essentially is like a signal to a disease. It not the disease, but you can actually have that detection towards that using, all this vast amount of data that is available, whether it's from a medical imaging or from, on a different level. It created a new around an area. So this is actually something that we feel very, passionate about, and actually there's a great opportunity.
So AI in early detection seems to be a huge opportunity.
Yes.
But one of the issues that's always occurred with diagnostics is that from an insurance point of view, it has the lowest reimbursement.
Yeah.
So, I mean, you're preventing disease, so you're doing good, right?
Uh-huh.
But it doesn't necessarily get the most, if you get terminally ill, you're going to get paid a bunch of money for medicines that
Yeah.
will prolong your life, right?
Yeah. Yeah.
That the same thing doesn't really happen with, so how do you balance the expectation of, diagnostics versus therapeutics?
Actually, that's a great question. So actually, you're absolutely right. And I would actually add to the point that actually diagnostics actually has a little bit more advantage than the therapeutics. While therapeutics, first of all, is a long process, it's an expensive process. Developing a drugs usually take $1 billion, take 10 years. So from an investment point of view, that's actually a little bit more challenging. So from a diagnostic point of view, actually it has a little more advantage. So a lot of the companies that we looked at, the way they kind of structured the deal is that there's a very clear what we call a 510K approval process. By 510K, essentially you have like a medical technology or medical devices you want to bring it to the market. And in order to bring a market, you have to find sort of like a predicate, in the market, and predicate meaning an existing devices that do the same thing.
Right.
So you actually do that, and actually allows you to use that pathway. That now I have this thing called AI that allows me to find the discovery much faster than the existing devices here. So actually that provide value, and actually that also. Because of that, you will get the reimbursement code because there's an existing devices. Doctors are we prescribe the same services because it's a better service, it's a better product.
One of the big questions all healthcare investors ask is who's the payor?
Yeah.
And you're saying that when there's already an insurance code, it makes
Absolutely.
getting to that payor that much
Yes,
faster.
absolutely. You got it right. So actually, from a investment point of view, it's very clear because you have a line of sight as opposed to wait until the 10 years, to see whether this thing is going to happen or not. But of course, there's from a therapeutics development, there's also kind of like, things where you can provide different value add, not only just from a therapeutics development, just say, you can use data and actually AI in this case here for say, look for how can I select the patient population? Because clinical trials is also one of the huge issues, finding the right patients to actually do your testing, and AI can help a lot. So it's not necessarily improving the end goal, but you will actually improve a lot of incremental points in between it. then eventually can lead to the big prize at the end.
Yeah, it's really interesting. I mean, so you look at diagnostics, and all of a sudden you may have a pool that's 5 times larger. That's pretty. I mean, because I'll give you a great example from our work with Stand Up to Cancer. What we found out is around only 5% of people, or 10% who should be getting screened for cancers early on, are getting the screening. It's 5% as a number. And if another, if it went up to 10%, which would double the number, it would kind of break the system, because the system isn't really structured, to prevent. It's structured to treat.
Well, not only the absolute number, right? It's just the qualified, the more the candidates that are supposed to be used as screening, say you want to hide even the higher risk population. And then you can use AI to actually select those patients for those diagnostics, So I think at the end, you have you improve that, the outcome, which is the most important aspect. It's not about just like you have this AI tool, right? So we need to look at how we want to improve the patient outcome. Right. So that is the most important part, right? So this is something where we look at.
So are you actually, when you look at a device that you're going to, invest in potentially because of AI, is it a brand new device, or is it a device that's maybe augmented to reinterpret the data that the existing device already produces? Or is it both?
Well, I think so. I think we have maybe too deep into the medical device here, but I think there's actually one area that I want to bring out. There's actually a regulatory pathway called software as a medical device approval. It's similar to FDA 510K, but it's for software.
What's the timing on that?
It's similar. It's basically, it's actually even faster than
we're talking like a 2-year approval time?
Even shorter. So the idea is that really as a software, think of it as you are just testing software. So now you look at, make sure it works, make sure it's a security, make sure it's, that's what it's supposed to do here. So if you recruit that, have patient data that can prove that, you can actually do, generally without actually say, I think medical device has a little bit more advantage, especially if you just try to look at, if you're using a very strong data point to prove that. I think that actually you will actually have a better, I won't say easier, but it's just like, it's not as a hurdle that we usually always think about medical products.
So we're talking about AI in diagnostics, but we're not talking about AI in treatments. And something that I like to say is that I think it's around 25 to 35% of all therapeutics that are prescribed by physicians, they go to specialty pharmacists, right? Specialty pharmacy is growing larger and larger. It gets back to the whole customization approach of healthcare that you're talking, personalization, right? And some doctors say, well, because of who you are and what you look like, or your weight, or your age, you need twice as much or a quarter of as much of a. So we're gonna go to a specialty pharmacist. So do you see AI touching that space as well? The prescription of the therapeutics.
Well, I think that actually leads to a different area. So we actually recently invested in a company called Persist AI. They are not. They're also for drug. Actually, they're focusing on what we call a drug formulations or reformulations. It's actually addressing the manufacturing problem. So to answer your question, yes, it is. We look at AI, but not so much for the therapeutics development, but we're actually looking AI for how can we expand the manufacturing capability. So the idea behind this Persist AI, they use this AI data and then microfluidics, which is actually look at the basically the study of fluids. How do you actually manipulate the molecules or the drugs so that you can actually get to the patient at the right target, and essentially say have a longer lasting, they call long injectables. So part of the problem behind that is I think one of the most recent, some of the news that we hear other than AI, there's another kind of area called GLP-1s, which is the obesity drugs.
Right.
So Eli Lilly and the Novo Nordisk of the world are the leader, right? But right now one of the challenges that they are very expensive. Other than the fact that and other problems surrounding it, but they're expensive. You talk about $1,000 per month, and then there's a sort of like a shortage. And the reason for the shortage is because the manufacturing capabilities are not there.
Okay.
That's why they're charging this premium price. So what we invest in this AI company essentially is to how can we shorten, expanding the manufacturing capacity using robotics, using AI, using all these advanced technologies.
So make it more efficient.
Make it more efficient, and at the end, so we can actually make this so that we can drive down the price, and hopefully make it more available to the public, right? So, and by the way, Eli Lilly is a co-investor in this company. The reason is that they spent $3 billion on expanding their manufacturing, actually even more on the manufacturing capacity.
Right.
And they want to use this technology so that they can, as part of that expansion. So this is one of the reasons. So it's a little bit adjacent to what you're trying to look for, but I just want to kind of bring up, there's a whole kind of like behind the scenes that are happening other than just like, I want to look for the best therapeutics. But if you don't have the great manufacturing platform on the end, then actually there's still a bottleneck that you want to reach to the ultimate goal of like, reaching to the people who really need to have it.
Got it. Yeah. So, just taking a step back, I mean, let's say like in 2000, 2001, there was a big crash in the market, all the internet stocks were crashing, and, 25 years later, we look at things and we say, well, although a lot of the internet stocks crashed and burned, the internet is bigger than ever, right? And it's not just internet, it's Internet of Things, AI, et cetera.
Yeah.
In 5 to 10 years, where do you see AI evolving? I mean, AI isn't just machine learning, it's not just large language models, but where do you see it going in 5 to 10 years?
Well, I think right now, I think, going back, so we, on January, so I think, like before 2025, I think, everybody was really captured by this whole generative AI, ChatGPT, OpenAI. But at the beginning, there's this what we call a DeepSeek moment, and I talked about it in my last presentation. Essentially, just like causing a market panic, right? So that means NVIDIA lost their almost $600 billion in a day. So the question is really, so where does that go from now, right? So and then I think one of the most exciting things that we see as a VC investor is that a lot of applications are still missing. So I think, and that's where we want to focus on how AI is being transforming the applications. So how do we see it? I think actually one of the examples that I want to quote also is that I recently attended the NVIDIA GTC conference, which is the GPU technology conference. Just was held a couple of weeks ago. So one of the keynote, by Jensen Huang, he mentioned that, of course, first of all, everybody was talking about DeepSeek. So is NVIDIA still needed in the next 5 years? So he come out and basically dismissed that. Yes, you do. And the reason you continue to do that is because that, first of all, I think, from a DeepSeek mode, that DeepSeek, one of the capability is that it enables you to have this what we call a reasoning capability. And what that means is that because I call it like a thinking out loud capability, where the AI in this case is just like reasoning by itself, bringing it into different steps. And then from this point here, they will just say, well, because of that, it actually generate a very better results just of, because of that, right? So the question behind that is like, well, in order to do that is what we call, you still need the NVIDIA chips to do that. What we call inference compute, which is what essentially the training the data before, but now it's actually whenever you ask AI to give me an answer, you go for a bunch of stuff in order to generate the best answer, right? So
it's almost like an auto mechanic, sure.
Yeah, so basically that idea is that gives the hope, and then actually what Jensen said that is like, you guys don't worry, there's going to be still a huge demand of what, the reasoning model. And he also goes on that actually talks about that. That doesn't mean that, there's like everything is going to smooth sailing from that point. There's actually a natural contention where, yes, you want that intelligence level, what we call, the amount of tokens that you generate. But at the same time, I don't know if you have used like a DeepSeek recently, but when I try to ask for it, it just spewed out a bunch of stuff here. Takes you a long time, but you wait for that, right? So imagine you trying to go for a customer support. The customer is not going to wait for that to come out with that answer for like 10 minutes.
Yeah, nobody
right?
wants a
So the idea is
treatise
that-
on what's going on. Yeah.
So the idea is there's a contention or tension between the customer response time and also the intelligence level. Of course, the more tokens you generate is better.
Yeah.
But at the same time, you can't just ask for people to wait for 10 minutes to wait. So I think the idea behind that, how we see it, is really from an NVIDIA from infrastructure point of view, that at least that's what NVIDIA is pointing out, is that yes, they're building more powerful chips that are built on actually, not just for training, but for this inference compute that can satisfy the both aspects for the intelligence level as well as the sort of like the customer response time, right? So you have this kind of what they call frontier as an aspect. So to answer your question, how do I see it for the next 5 to 10 years?
Yep.
So that's the part where, it's a long answer to your question. Yes, the question is like going to shift towards from a data center centric kind of computation to what we call inference compute. And what that means is that we're going to translate or push it to applications such as, healthcare, how do you do, manufacturing, how do you do robotics, how do you do, the autonomy? At the end, all that intelligence are shifting to what we call not exactly the edge, but actually the opportunities like shift away from the data center centric to the edge, if you will, or to the application level. So that's where the innovations are going to come about. And that's actually where we want to invest here.
So, I mean, are you seeing that open source will be predominant versus proprietary models, or do you see a place for both of them, or do you see really the money being made one place or the other?
Well, I won't say it's a money-making process here. The way we look at here, I think open source or the DeepSeek, one of the key moments is that it really, come out as an open source model. And I think this is something where it's a driver for innovation. It's a spur of innovation. It's not so much about you can make more money that way, because I think we have to look at it as an industry, as an ecosystem where, everybody benefit from each other, not necessarily just like one's proprietary kind of company that you can just go all along. History has been proven that, that collaboration or the lack of collaboration will limit your growth. So open source is actually becoming a driver. So I think, funny thing is that whenever DeepSeek comes out, it's an open source model. And first of all, Sam Altman, who is the CEO of OpenAI, come out and slam against these guys immediately. Say he was sending President Trump and say, President Trump, you should ban them just like you banned TikTok.
Yeah, wasn't OpenAI originally open source?
Well, they were a nonprofit. That's another story. They were trying to build a problem to try to solve this AGI problem. But that's a different story. It's not about
Facebook is open source.
Yes, Facebook has an open source llama model. But again, I think this again to us is not necessarily just where you make money. So and I can actually give you a quick example.
Okay, great.
So this is this idea called, we heard about large language model, which is like basically what OpenAI does is like they're actually training data from everything from the internet, to build up a vast amount of data, right? So there's this idea called small language model.
Yeah.
So the idea is that really, let's say you are a hospital, right? So you want to say, I want to build up use an AI model, but based on my patients. So first of all, I don't really care about these other 10 billion things out there about, from movie scripts to whatever that you're looking at. All I care is that the patient data. What if I can actually specialized AI, a much smaller model? But the way they do it here is that before this open source model here available, they would say, well, the only way I can do that is that I need to hire OpenAI to train my data so that I can build up this model, right? So first of all, that's pretty expensive. OpenAI will do it for you, but you need to pay them, right? And second is like, well, now that you're talking about patients' data, are you willing to just throw it off to OpenAI to let them just go for it, right? So that created basically a challenge, right? But now with the open source model, now as a clinic, as a hospital, now I can actually just like download DeepSeek or other source of a model, and I train my model using my patient data, and you have absolute control of what needs to be, factored in, and then
Right.
and then all that. So that created an opportunity, right? So now, and I think that's something where we felt very excited. Now it's like, this emergence of this new opportunity or new innovations that are powering, different enterprises from individual to, companies.
Got it. Yeah,
Yeah.
interesting.
Yeah.
So I guess that we have, this contrast between OpenAI and DeepSeek, OpenAI and DeepSeek, but I have to think to myself, and maybe it's another application of AI. Why can't you use AI to kind of backwards look for how people are, hiding corporate secrets, or what's the next logical development in their own, corporate programs? I mean, it seems like that's something that AI would do, would almost be trivial for AI, because most companies use the same process to develop Advantage, right? So it seems to me, and that's not this is a Marty Sakata generated question,
Okay.
not an AI generated question. It's really about it seems it will be harder for humans to hide things from AI, right? Based on reasoning, et cetera. I mean, like, so one of the things that we looked at with Evercure when they're looking at developing data is that there's a lot of data in scientists' notes, right? From different pharmaceutical companies that refer to other uses of pharmaceuticals, et cetera. Is there that possibility of grabbing, data and how much that data is readily available, right? So, and the more advanced AI gets, the more it can assume things by reading stuff those same scientists have published in the media or in scientific journals, et cetera, right? So, I mean, it doesn't seem to me to be hard for people to kind of back into data using AI. And next steps I'm talking about from a strategy point of view, right? Because we're saying you've got open source versus, closed proprietary. And I'm saying that proprietary is going to become more and more difficult to preserve because AI can back into lots of things.
Yeah, I think that's probably true. But again, I think I'll focus on really that collaboration effort, right? So I think, some of the actually, that one point that I point out for DeepSeek is that there's actually there's another aspect of it. So I think first of all, they were developed in China, and people tend not to think China is the hub of innovation, right? So, and then also there's kind of like another headwind where there's like a lot of restriction for exporting, the NVIDIA chips, the GPU chips. So there's a question that how can these guys build up this powerful model with all these different restrictions around it? And they claim that they built the whole thing in $6 million. So that's yet to be proven. But, regardless, there's truly innovations that are coming out. If you look at how they do different process, how do they do reinforcement training and all that, how do they get to the smaller size, much more cost efficient? So innovation is happening. And why is that there's innovation? I think there's always this, I quoted is the necessity is the mother of invention.
That's a good one, yeah.
Because, when you don't have much, then you start to, really fight for it, right? So they figure out, let's think of something more creative, innovative, right? So, so idea is that you go back, so now the proprietary system is like, that's also kind of another factor that kind of surround it is that when you say proprietary system, they are funded by a lot of resources. So with that kind of like constraints or not constraint or latitude or flexibility, you tend to be less flexible. And yes, eventually you can go to like, get to the data and whatnot, right? but you really want to try to do that to kind of figure things out? So I think that's a more
Interesting.
as a more important aspects of, say, how we kind of push forward for the innovation,
Mhm.
as opposed to like who control the data and all that. And by the way, actually, that's in terms of data, I think this is something. I think one of the questions that you mentioned is that what kind of AI companies that we want to look at. So I think we look at healthcare, AI and all that, right? So one of the key thesis is that where do they get, let's say I have a medical imaging, AI company doing diagnostics.
Yep.
But I want to say build up the data model. But where do you get your patient's data, right? So we talked about, if you're a hospital, you only can access to that. So the value of AI comes from data. They are not coming from what we call algorithms, So that's a very true. So going back to that example where, you have to essentially, if you have that kind of medical imaging data, somehow you have access as a startup or as a hospital, that become your IPs, your intellectual properties, right?
Yep.
And then if that's the case here, that become your advantage. And then that become, you can actually say, and that's where the application, if the opportunity where it's no longer to say the OpenAI or the NVIDIA of the world, they don't have access to that data, but you do as a startup or that company. And that's actually, we look at companies that have that, data moat, that advantages, and that actually would create, a much more better advantage as an AI company.
Sure. We've got about 5 minutes to the
Okay.
lightning round, so it's a couple of questions.
Okay.
So, what's the most exciting part of AI today? I mean, you've looked at it in terms of healthcare, blockchain, cybersecurity, fintech, analytics. What excites you the most?
So we talk about robotics. Well, actually, we didn't talk much about robotics, right? So I think that's something where we're very passionate about. So, and actually, going back to the Jensen's keynote, he was talking about this adoption, the AI opportunity for the next 5 to 10 years, right? So we talk about reasoning, and there's another area called agentic AI, which is basically AI that apply as an agent. And I can talk about that a little bit later. But also the last part is what we call physical AI. For physical AI, essentially, we talk about robotics, autonomous driving. So these are the roadmap. So NVIDIA is not just going to be chips sitting in the data center or your computer anymore. It's going to be sitting in your car, sitting in your robotics, and doing exactly the same AI capability that you enjoy using when you try to, work with, ChatGPT or not, So, and that's actually something we care. I mean, the whole idea where, now we actually, what we call text-based tokens, when we actually talk to ChatGPT, you have to text or generate image. But, what about we can actually tokenize actions, right? A robot can now learn from a human for operation, say, how can I move this table from point A to point B, right?
Yep.
So it's full training. It's not built by algorithm, right? So you have to train the robot in order to do that. So actually, that's where the new opportunity.
Right.
So this is something we felt very excited about.
Right. So if you have children and a robot's not used to them, you have to train it to walk around them, not over them, right?
Yeah. So think of a case, right? If you like, I have, in a warehouse, if I want to move stuff, say from point A to point B, right? So you used to rely on maybe a human or a forklift, whatnot, right? So now you can actually have robots, but the robot is like, there's so many different obstacles, right? What if something falls? What if somebody knock you down? What if you have something where, you need to have kind of you do that, you react based on some sort of previous training. You can't just use some sort of algorithm. So if you just actually give tell the robot instruction to do that, so they can actually handle all that part, right? So now this is the part where, the potential use case and applications in that case.
Right. So when you look at your investments, because you've been investing for a while now, how do you look at things in terms of being like a green field where there's nothing in that application right now versus there's already an existing champion in the space? And does that impact your decision to invest?
Well, I think there's no I won't say there's any green field right now. I think AI has been kind of like, has been happening for a lot of, so I think we're what we call should be a nascent stage of development is what
Yes.
so I mean, we talk a lot about healthcare, right? So, and I think I would kind of double click on, say, like on the healthcare again, how we do diagnostics. And actually, there's a labor shortage in general, say for healthcare workers. So if AI, how we can actually use AI to improve that, I think that's it's a green space, because then a lot of things are people, you're building AI for the sake of AI. You're not building an AI for a particular problem. So that's in healthcare, for example, there's overworked, burnout doctors. How can we kind of improve anything that is mundane, repetitive,
Yep.
and take that out of their loop, right? They're not trained to doctors are not trained to do paperwork. If there's AI can help that to improve and actually improve the treatment process, help them make better decisions, right? So a doctor is not going to look at like 10,000, patient's record,
Right.
to decide what to do next, right? But AI can help. So these are the opportunities. And I think, I would say low hanging fruits, as opposed to like, a green field.
Right. It seems that you want to hit the low hanging fruit first and then continue on to the other innovation. So this has been a great round. We're going to take a 2-minute break
Okay.
to prepare for the lightning round.
Okay.
And then we'll get to that.
Okay.
As soon as you're ready.
Okay.
Thanks.
Sounds good.
So we're back here for the lightning round. And as I said, Darwin, you're one of the biggest insiders I know in the AI space. What's the biggest breakthrough of 2025 so far?
DeepSeek.
Great. Underrated AI sector.
Cybersecurity.
China's edge in AI. What's one area we think China has an edge over the USA in AI development?
I think the edge is really, I talk about DeepSeek, and more specifically talk about the culture. How is it different than what the old tradition where we think AI is a copycat in general. So I think there's a fresh talents, and there's a lot of strong government support. I think that's just the AI edge.
New innovation, huh?
Yeah.
What's the USA's edge in AI?
I think it's still on the infrastructure, capital. This is actually the edge. Of course, we own on the semiconductors, and then, but idea is that itself at that edge is not going to be sustainable. Giving, I talk about this necessity of modern invention. So China is going to continue to develop new infrastructure to support that. And eventually, I think they will catch up.
What do you see as the impact of open source AI models on the competitive landscape?
Again, it's a spur of innovation. It creates new business models, and because of openness of data access also, right? So that's actually, that transparency will create an advantage. And for people who can capture that data advantages, they will become the next unicorn for AI companies.
Will proprietary models remain dominant over the long term, or are they going to lose ground?
Definitely not.
What is an AI investment strategy based on today's environment?
I would say this should not be just a AI investment strategy. It's just a general investment strategy. I think we are being captured by this Magnificent Seven and also on the S&P 500. AI is only dominated by the 7 companies, and actually that's not true. And we see the market just tumble because of all that, AI. So I think the key word is that try to diversify to different asset class and potentially different sectors.
What's the most overhyped AI trend?
I think I like to say quantum on AI, not quantum by itself. Quantum computing, there's a lot of always talk about quantum computing is going to be accelerated AI, but fundamentally quantum is a different science and different technology. It solves a different set of problems than AI. So when people say we're using quantum computing to create a new AI engine, that's the overhyped thing.
What advice do you have for AI founders? What's the one thing that you would tell them when pitching their startup?
So I think focus on the price. we tend to, when we invest in companies, we look at three parameters: product, market, and team. So focus on the fundamentals. Do not just, try to build an AI company just for the sake so that you can attract VC's attention. Try to focus on what the product is, who your customers are, and recruit a great team to build a product. And you will serve you very well at this moment.
What's the next big frontier in AI that investors should be watching?
Next frontier in AI. So I guess I talked about that. That's like we talk about agentic AI,
Right.
and also the physical AI. We talk about these two things.
Small language models?
Small language model is an offshoot for that open source. So agentic AI is essentially so think of an example where if I'm planning a trip, so right now if you ask OpenAI, they would just say, oh, which hotel you should stay at, right? If you just kind of give the high level description of what you want to do, they will plan out the entire trip. So you might have a very specialized agent to say, find your cheapest ticket, and then another agent to coordinate your, holiday schedule. And then third is like, make sure you don't have the best result so that your wife and kids won't get pissed off and all that, right? So the thing is,
sounds like a great application to me.
That's exactly a great use case, right? So
there you go.
So basically it's a breaking down into different specialized things, and you can extend that to healthcare applications. You can extend it to manufacturing. You can extend it to all these different kind of vertical domain we talked about.
Well, fantastic, Darwin. Listen, great to have you back, and we're looking forward to seeing you again. Always great to have you.
Thank you so much.
Thank
you so
you.
much.
Cheers.